tips and tricks. And so in our second week, we're primarily focusing on the transition to Lab 2, but can see some have joined. So we're glad to take some question and answer. And I think even in the process of looking at Lab 2, there'll be some things resolved in terms of people's questions with regard to Lab 1 and being successful with that. And of course, our overall focus has always been successful and empowering people with data. So without further ado, we have our expert here. Chloe can take us through some information. So I think there, I'll leave the stage to you.
Okay, so just my title, this is Tips and Tricks, and I'm focusing on Lab 2, and it is conversion and equation focused, just because I noticed that throughout the lab, it's a lot of questions that involve conversions, either in the coding or before the coding. And because the coding is so finicky and Python only takes like very specific numbers, decimal points, parentheses, etc., it is just very important to correct these things before, like later labs when you do conversions and you forget and then you can't find out what's wrong, and it's just not something you want to deal with. So I just did a little title slide. I'm a sophomore in biology, and here are my office hours in case you're watching this back and you're interested in joining, and I have my email under there in case you need to contact me. So for this slide, I just wanted to do some basic reminders in case you didn't know how to get started or you didn't hear in class how to do the exporting and renaming. So I have a Mac. I'm not sure if this works for everybody, but if I double click with on both sides on my right and my mouse pad, or my right and my left mouse pad, I'm able to pull this up for renaming. So you should just be able to click it and then rename your file so you don't get confused with the copy. And then after that, I do recommend running all your, sorry, it just changed at the top. Running all your cells before you submit them, and running all your cells when you first open the kernel. That way everything is kind of up to date and you can see if there are anything wrong, or if your test didn't pass, or just if like the little cells don't pass in between, sometimes the code won't run. So that's super important. And then over here, I have how to do the HTML. You have to go to save and export and then HTML. For the download, you can just click download and then bring it from your Dropbox into the Canvas Dropbox, and it should submit just fine. So for question 1, this was one of the first conversion questions. It just asked for the time and estimated distance, which it doesn't seem difficult. Obviously, it says the time right over here. But you can see that in the question, it's 113 centimeters, but in the code, it asks for meters. So that's just one of those small things that you think you know the answer right away, but you have to go back and check the conversion before you run the code. For question 2, it kind of has this little equation down here in the ellipsis. You can see that above here, if you didn't know where to start, you have the equation, you have all the different variables, and it actually tells you how the variable matches up with this. So you can arrange your equation. And I put over here to double check your parentheses and place exponents as needed, because as you can see, there's a big difference between multiplication and exponents, and it's just important to remember those differences so everything runs smoothly. And then for question 4, I just wanted to put one of these maps in here because the visuals can be so helpful, especially because this is just a small section of what the instructions have, but a lot of them can be longer, or they can go from 1 to 2 questions. And it can be a little confusing because there's just so much information, so many numbers in such a small paragraph. So the visuals can really help break it down, as you can see over here with the ABS 4234 right over here. And then down here, you can see how it matches up over here. So just using the visuals and placing them into the questions, again, can really be helpful when setting up equations like this. Again, for question 9, it is a conversion question. Oh, sorry. But this time it's using dot replace, which is a different method than was used previously. So it's pretty simple, just another example of how conversions can be done. And how to make the changes. Again, a reminder of how case sensitive Python can be. As we can see, there's a uppercase L and an uppercase K. So just make sure to be doing those to make sure everything runs, and you don't have to go back and look for those little mistakes. And then for question 10, I noticed that some of the questions that just have the ... dots can be confusing because where are you supposed to start? It feels like there's a lot of information on here, but if you really read into it, it's the same information. It can just be strange with a lot of things are fill in the blank. So where to start in that, I have arrows pointing to the functions that it'll be using, and you can use that as a starting point. Again, this is another example of how the visuals can be helpful, because if you read the question, you can kind of see how the information that you need to use for the rest of it's right here. And then for my last question I pulled is, again, another conversion. This time it's from meters to feet, but you're going to have to use the multiplication to do it instead of just the conversion or the dot replace. You just need to find it for all four of them. So you just have to remember, again, with the capitalizing, lowercase, parentheses, and the correct, not inequalities, crap, I can't remember what they're called. Operations. And that is all that I had.
In a nutshell, those are some of the key things I think can see nicely. For instance, we were struggling with some of the parentheses and so forth with lab 1 with the expression. Now it comes into play when we're doing something more complex, like with the acceleration of gravity and things of this sort. Do you remember which part of lab 2 did you find most challenging? If you can rewind.
I want to say, because I looked over it the other day, I want to say it was the one where it had, I think it was question 4, where it had all the different, you had to put it in and then you had to do the multiplication for, what was it? It wasn't the conversion. It was the gravity constant one where it like equaled it and then you just set it up. I said that was probably one of the more difficult ones on there.
Yeah. So there are a number of challenging ones. It's great that you got into the conversion with the list comprehension. At least that's what we call it in terms of making the conversion. So it reaches for each of the height of the peak in meter, and then it picks each of those and will apply that conversion. So you get a new list. So that's really nice. I think I see a question in the chat. So let's see. Okay, looks like a question about submitting the lab assignment. So should we submit the IPYNB file as well? So what do you think, Chloe?
So I'm not sure if you have the same instructor that I have, but our instructor wanted us to rename the file and then submit both of them just in case he can't view it. A bunch of different computers and different programs sometimes won't pull up certain things, or some computers are just dumb and they won't allow it for another reason. So it's good to submit both of them. That way you can avoid having to, not that going into office hours is bad, but having to put an extra conflict in your grading and having to wait the time. It's just easier to submit both of them and not have any issues.
So let's say it's lab 2. Now, what we were talking about here, you can, for instance, duplicate it, and then you can rename it. Like here, I could put, JMS with my initials. And now here, there is one download here, but probably the easiest way is if we now open this one, so it's going to be a copy of lab 2. The reason I'm opening it is because the file will be associated with this one that we see here. So let's say everything's done. It isn't. It's only started. Then here you can click download. And on my computer, that download will go to a folder called downloads, okay? It will vary again by computer. Then here is the save and export as HTML. So depending on the computer, you may get a screen like this where it goes blank. That is okay. You can. It isn't lab 1, but let's say it is. So here's the upload button. Don't get much action there, but here, if you click here, now I can go to the downloads and I can select both of the files. I'm not sure if you see my dialog on that. And now it shows both of them here. So I can submit that. And it's done. I don't know if that helped. Okay, I got it. Good. Yeah. So I guess over in here, great. Are there other questions in terms of the notebook itself out there? I see the two of you have joined us, so if you want to shout out with another question, something that you're thinking about, that's super. Okay, thanks. Yeah, great. So I did copy over these two cases. So for a moment we can build on this, and then we're pretty much done if there aren't any further questions. So here, as Chloe said, this is a list. So now we have the list of these Adirondack peaks. That's what the ADK stands for. And then this conversion. So want to think what the conversion is for meters to feet. Now, one way I think about it, certainly good idea to look it up, okay? But I don't know if this helps at all, because you may not think in terms of 3 feet being a yard and a yard being similar in distance to a meter. So that's one way to get an order of magnitude. So it's good to have some sense of what the number is roughly. But we can look up these conversions. Meter to feet. So it's 3.28. So it's a little larger than I was saying. So that's what goes here. Okay. And then in here, we're going to do something. I'm not going to show exactly how to do it, but let's say we took 1629 meters. So if we took 3.28 times 629, then that is the number of feet that corresponds to 1,629 meters. So the point is, where the 3 ellipses are, we want something that takes this variable meter and multiplies it by 3.28. So if I did the wrong thing, I would just say meter here, okay? And to echo that result, we have to type this again. So here we see we get the same number, because what's happening here, it's picking out from each of these values in the list, and this in is looking inside this list and picking out the value in meters. Now, this doesn't have to be labeled meter, but it's labeled meter for convenience. So we get each of these values. Here, all that's happening is it's taking that meter and putting it here. So let's say instead I wanted centimeter. So centimeter, if we go from meters, to centimeter, what is the factor there? It's going to be 100. So here we would put 100 times, okay? So now you can see in a little simpler example, we've just moved the decimal place over 2 positions because we multiplied by 100. And these are the heights in centimeters as opposed to in meters. If we wanted to do it in kilometers, then we could divide by 1,000, for instance. We don't have to change the variable name, but probably a good idea. So now we can see this one at 1.629 is actually just a little over 1 mile high, because 1 mile is 1,600, about 1,600 meters. I know that because in college I ran track. So in track, we did a 1,600 meter, which is a metric mile. So that's why this first peak, the highest peak, is a little over a mile high. So that's pretty high. So this is where we would do the action in terms of applying this kind of idea. So it's a little tip on that one. The above one, I've noticed that some people have had trouble because they haven't applied the replace twice. So sometimes it's helpful if we break this apart. So if we take this one and execute it, and then we only do it once. So here, like this. If we do it once, you see that we get 300 minus 273.15. That was the first step. Then we can logically apply a similar step to remove this, because this, if we try to evaluate this, this is what I've noticed a number of people doing, it gives us an error, okay? Because here it says invalid decimal literal. Well, that's kind of a subtle message, but this L here, you cannot evaluate the expression with L in it because L has no value. It's just a unit. So that's where we run into trouble with this piece. So I would say the real step 2 would be to then, maybe having split this up, we could remove this piece. And then here, this is where the expression would go that would remove this L. And if we're going here to milliliters, then 1 liter is 1,000 milliliters. So just like Chloe said, this is a matter of conversions sometimes, but conversions are important for scientists to do, whether in chemistry, biology, EEB, or wherever you might be. So those are important. So instead of replacing the liter with nothing, that's where we might replace the liter with times 1,000 as an idea. And then down here, we could put this gas data convert, once that conversion is completed, into here. And then things should go along nicely. So then this kind of structure picks up the gas data and the gas data convert, and we'll display it appropriately.